Welcome back to Algebra 2, Chapter 6, Section 6 in this book. And we're going to continue with our ideas of synthetic division called finding rational zeros. So what this means is, if you remember last time, that we did a synthetic division and we found that the remainder was 0, so we knew that it was a factor. So this is a way to find factors, and I'll explain the wording a little bit more. Okay, so here I have and remember how I told you when we tried to find the factors of these ugly things that you look for patterns, you see if you can pull anything out, you go with your gut, you do it wrong, you rip it up. Okay, this is the secret of not having to do all that. Yay! Okay, so here I have this thing that I want to factor. There's nothing I can pull out. I can't do the factoring by grouping. It's just a mess. Well, there's this thing called the rational zeros theorem, and it said that you can get the factors using synthetic division, and instead of trying every number in the universe in infinity, we can limit the ones to start trying with to this. You take the factors of the bare number and you put them in the numerator, and the factors of the leading coefficient, and those go in the denominator, and it's plus or minus. Let me show you what I mean. Okay, so the factors of 12 are 1 and 12, 2 and 6, 3 and 4. There's our big U. If you don't know how to do that, go watch one of the other videos. The factors of 1 are just 1. So I know everything in my denominator is going to be 1, because that's all I got for factors of my leading coefficient. And when it's like that, you're cooking with gas. That's good. It's going to be easier. Okay, so now what I do is for each one of these, I put it in the numerator, but it's plus or minus. So I just put them on top. 1, 2, 3, 4, 6, 12. And then I do the fractions. 1 divided by 1 is 1. But I have to have it plus and minus. So it's 1, negative 1, 2, negative 2, 3, negative 3, 6, negative 6, 12, negative 12. And now instead of trying every number in the universe with synthetic division, trying to find one that has a 0 for a remainder, I only have 10 numbers to try. And synthetic division's fun. So let's do one. So I started with positive 1 to try. And so I put it here, and then I wrote my coefficients here, 1, 2, negative 11, negative 12. I put my big L, I brought down the 1, I put plus here and multiply here. 1 times 1 is 1. 2 plus 1 is 3. 1 times 3 is 3. Negative 11 plus 3 is negative 8. 1 times negative 8 is negative 8. Negative 12 minus negative 8 is negative 20. Is that a 0? No. This is not a factor. Okay? So 1 down, 9 to go. So I try my next one. Negative 1. I draw my L. I bring down the 1 and I start my multiplying. Negative 1 times 1 is negative 1. 2 minus 1 is 1. Negative 1 times 1 is negative 1. Negative 11 minus 1 is negative 12. Negative 1 times negative 12, two negatives make a positive, is 12. 12 minus 12 is 0. Yay! Woohoo! We found one. So we know the opposite sign of this is one of the factors. So we found one. It is x plus 1. And remember, we can put what it's being multiplied. That's the bare number, that's the x term, and that's the x squared term. That's still the remainder. We don't do anything with it. So it's going to be x squared plus x minus 12 is my other factor. But I can factor that. The factors of 12 are 1 and 12, 2 and 6, 3 and 4. Which of those could be added or subtracted to get 1? There's only 1, 3 and 4. So I put my 3 and my 4. The bigger number gets the sign of the middle term, so this is x plus 4, and to make this negative, that has to be negative. So my 3 factors of this are x plus 1, x minus 3, and x plus 4, and my solutions are negative 1, positive 3, and negative 4. So if I graphed that thing, it would cross the x-axis in those 3 places. Okay? Now, this is how far I want you to understand this. I want you to be able to do what I just did. If this one had been a no, then we'd go on to 2. If that had been a no, we'd go on to negative 2. And I always start with the little numbers because they're easier and I'm lazy. I don't start with negative 12. I'll do it if I have to. But you keep going until you find 1. And once you find 1, usually you're off and running. So I want you to understand this. I want you to study the examples in the book, make sure they make sense to you, and then I want you to do your homework. But I think this is a super fun part of Algebra 2. I hope you do too. Math is great.